Hello everyone. So guys, I'm starting with the Euler number theorem to find the remainder. This is part 2 of the course. Am I audible? Am I visible? Guys, I'm starting with the Euler number theorem. Can you guys listen to my voice? So in the last class that I took yesterday, we did the basic remainder theorem, right? We did the concept of Euler remainder theorem, how to find out the Euler number and what is the basic remainder theorem. We have done some basic questions of remainder on the concept, using the concept of Euler remainder. In this video lesson, I'm going to talk about the second part of Euler number theorem, where we will be doing some advanced level questions where the power of power is given. So how to solve the questions which are of advanced level and how Euler remainder theorem can help us to solve these questions. I am going to take that part in today's class. So before I start with the session, let me remind you the basic concept that we have covered in the last class. The meaning of Euler number that we have discussed earlier in detail is that all natural numbers which are less than x and are co-prime to x. The Euler number of a natural number x means the numbers of natural numbers which are less than x and are co-prime to x. Or now what is the meaning of co-prime? Two numbers are said to be co-prime when their HCF is 1, right? We have talked about it earlier. For example, if I want to find out the Euler number of 6, I need to see how many numbers less than 6 are co-prime to 6. So there are total 5 numbers which are less than 6, and out of these 5 numbers, 1 is co-prime with 6, 2 is not co-prime, 3 is not co-prime with 6, 4 is not co-prime with 6, and 5 is co-prime with 6. So you will say the Euler number of 6 is 2, right? And there's an alternate method of finding the Euler number that I explained to you in the previous video class, that Euler number of any natural number n can be found out by applying this formula, which the derivation of which has been explained to you earlier, that Euler number of a natural number n means the number n itself into 1 minus 1 upon a into 1 minus 1 upon b into 1 minus 1 upon c. And what is these a, b and c are? A, b, c are the prime factors of a natural number n. For example, if I want to find out the Euler number of 100, right? If you want to find out the Euler number of 100, you just factorize the 100 first. 100 can be factorized as 2 power 2 into 5 power 2. Now if you want to find out all the numbers which are less than 100 and are co-prime to 100, so you will apply this formula. What is the meaning of this formula? That out of the 100 numbers, every second number is a multiple of 2. So you will remove half of the numbers, so you will be left with half of the remaining number. After that, every fifth number is a multiple of 5, so you will remove 1/5 of the remaining numbers, so you will be left with 4/5 of the number. So basically the Euler number of 100 would be 100 into 1 minus 1 by 2 into is 1 by 2, 1 minus 1 upon 5 is 4 by 5. Solving it, you will get a value of 40. So that means there are 40 natural numbers which are less than 100 and are co-prime to 100, right? So this concept has been explained to you in the previous video class, previous live class. Now, what does Euler remainder theorem states? The Euler remainder theorem states that when a power n is divided by b, where n is a Euler number of b and a and b are co-prime to each other, remainder will always be 1. For example, if a power n is divided by b, now if a and b are co-prime with each other and n is a multiple of Euler number of b, in that case remainder will be 1, right? This is the remainder Euler remainder theorem. Two conditions that you are supposed to check, that a and b should be the co-prime with each other and this power should be a multiple of Euler number of b. If these two conditions are getting satisfied, you can say the remainder will be 1. For example, in this case, if you want to find out the remainder when 37 power 100 is divided by 11, you can check 37 and 11 are co-prime with each other. Now, if I want to find out the Euler number of 11, now 11 is a prime number. For every prime number, Euler number would be 1 less than the prime number. Why? Because 11 will made co-prime with all the numbers which are less than 11, because 11 itself is a prime number. So Euler number of 11 will be 10 and 100 is a multiple of 10. So straight away you can say the answer of this question would be 1. That means remainder will be 1. Do you understand this concept? Right? यहाँ तक concept आप सबका clear होना चाहिए. Anyone having doubt, please ask. So before we start with the advanced level questions, please solve these 3 questions that you can see on the screen with the help of remainder theorem, and please comment your answers. Solve these 3 questions which are based on the basic concept of Euler remainder theorem, and then we will move on to the advanced level questions, which is the agenda of this agenda of today's class. Solve these 3 questions, guys. Use the concept of Euler remainder theorem to answer these questions. Remember, two conditions need to be satisfied. A and B should be co-prime and the power should be a multiple of Euler number of divisor. That's it. Then remainder will be 1. So what will be the answer of this question? When 7 power 165 is divided by 17, what will be the answer? Come on guys, comment. So let me explain you the solution. See, when 7 power 165 is divided by 16, as per the Euler remainder theorem, you are supposed to check first whether 7 and 16 are co-prime with each other or not. Sorry, 7 divided by 17. It's not 16, it's 17. You are supposed to check 7 and 17 are co-prime with each other or not. Yes, 7 and 17 are co-prime. Now, what is the Euler number of 17? The Euler number of 17 is 16, right? Why it is 16? Because 17 is a prime number. For all prime numbers, Euler number is just 1 less than the prime number itself, right? Because prime number will be co-prime to all the numbers which are less than that prime number. Now, you are supposed to see whether the power is a multiple of 16 or not. Now, in this case, power is not a multiple of 16. But if it is not a multiple of 16, you can rewrite this numerator part to make it a multiple of 16. What you can do is 7 power 165 can be written as 7 power 160 into 7 power 5 divided by 17. Now, from this part, if you can see 7 power 160 when divided by 17, you can see you can apply the Euler remainder theorem here. 7 and 17 are co-prime. The Euler number of 17 is 16 and this power is a multiple of 16, right? So this part will give you a remainder of 1. So what you will be left with is 7 power 5. Now 7 power 5 is what? 7 power 2 into 7 power 2 into 7. This can be written like this, divided by 17. Now 7 power 2 is 49. Second 7 power 2 again 49 into 7 divided by 17. Now you can use the basic concept of remainder theorem. 49 when divided by 17 will give you a remainder of minus 2, right? Because 17 into 3 is 51. So 49 minus 51 would be minus 2. So this 49 will also give you a remainder of minus 2 into 7 divided by 17. Now minus 2 into 7 is 28. Now 28 when divided by 17 will give you a remainder of 11. So you will say the question of the answer of the first question would be 11. All right. Have you understood the concept? Shall we move on to the next question? Come on guys, reply in the comment section. Have you understood this question? सबको समझ आ गया ये question? Because अगर आपको ये first part नहीं है, basic questions अगर आप अच्छे से नहीं कर पा रहे हैं, then the advanced you will not be able to solve the advanced level questions. All right. So the first answer to the first question would be 11. I'm moving to the next question, right? So first question answer is 11. What will be the answer of the second part? Solve this question. 50 power 146 is divided by 21. Now check when 50 power 146 is divided by 21. First condition that you are supposed to check is whether 50 and 21 are co-prime with each other or not. If you check 50 and 21, they do not have any common factor except 1. So you can say 50 and 21 are co-prime with each other. Now next part is to find out the Euler number of 21, and you will have to check whether the power is a multiple of Euler number of 21 or not. Now let's find out the Euler number of 21. Now 21 can be written as 3 into 7. This is the factorization of 21. So if you want to find out the Euler number of 21, it would be 21 into 1 minus 1 by 3 into 1 minus 1 upon 7. Now this can be written as 21 into 2 by 3 into 1 minus 1 by 7 is 6 by 7. So 7 into 3 is 21, which will get cancelled. So 2 into 6 is 12. So now you get to know the Euler number of 21 is 12, right? So now if Euler number of 21 is 12, you will have to see that what will be the remainder when the power of 50 is divided by 12. We have just seen the Euler number of 21 is 12. So you'll have to see whether this power is a multiple of 12 or not. It is not. So what we will do is we will try to make it a multiple of 12. 50 power 146 can be written as 50 power 144 into 50 power 2 divided by 21. Now this part of this question will give you a remainder of 1. Now this will give you a remainder of 1 using the concept of Euler remainder theorem, which states if these two numbers are co-prime with each other and this is a multiple of Euler number of 21. Now multiple of Euler number of 21 is 12 and 144 is a multiple of 12. So remainder will be 1. So you will be left with only 50, that is 50 into 50 divided by 21. Now 50 when divided by 21 will give you a remainder of 8. And 50 divided by 21 you will give you a remainder of 8. So you will have 64 in the numerator. Now 64 upon 21, what will be the answer? If you divide 64 by 21, you will have the answer as 1. So in this case, the remainder will be 1. This would be the answer of this question. So the second question have the answer as 1, right? In this case, remainder will be 1. Do the question number 3 using the concept of Euler remainder theorem. Try it by yourself. I am giving you a minute to solve it. Comment your answers. Do the question number 3. 65 power 218 when divided by 18. So 65 power 218 when divided by 18, what will be the remainder? Check the condition first. These two numbers should be co-prime with each other, 65 and 18. Whether they are co-prime with each other, yes, they are co-prime. How would you get to know they are co-prime? Because if you do the factorization of 65, 65 is 5 into 13 and 18 is 2 into 3 power 2. You can see that none of the prime factor is common. So that means 65 and 18 are co-prime with each other. Now the next step is to find out the Euler number of 18. How would you find out the Euler number of 18? First you will have to factorize it, which we have already done. So if you want to find out the Euler number of 18, apply the base concept of Euler number, right? 18 into 1 minus 1 by 2 is 1 by 2 and 1 minus 1 by 3 will be 2 by 3. So the Euler number of 18 would be 3 into 2 is 6, 6 into 3 is 18, so 3 into 2 is 6. Euler number of 18 is 6. Now you'll have to see whether the power is a multiple of 6 or not. If you can see, the power is 218, which is not a multiple of 6, but 216 is a multiple of 6, so this can be written as 65 power 216 into 65 power 2 divided by 18. Now using the Euler remainder theorem, you can see that this part will give you a remainder of 1. Now this will give you a remainder of 1, so you will be left with only 265. So 65 into 65 upon 18. We'll have to check for this part only. Now 65 and divided by 18 will give you a remainder of, when 65 18 into 3 is 54. So 65 will give you remainder of 11. This 65 will also give you remainder of 11. 11 into 11 is 121. So to answer the question, you are supposed to divide 121 by 18. Now when 121 is divided by 18, what will be the remainder? Please comment. 18 into 6 is 108. So 121 minus 108 would be 13. So in this case, the answer would be 13. The answer to the third question would be 13. Alright. So these are the basic questions that we have also done in the previous class of Euler remainder theorem, where we have discussed the basic part of Euler remainder theorem. Now the purpose of this class was to discuss some advanced level question where the power of power is given. The questions which have a composite index, right? So I'm moving to the next question. We have done the 5 questions based on the Euler remainder theorem in the previous video class. So I'm starting with the question number 6. These 3 questions that we have discussed in the previous slide were the basic question, just to remind you the concept. Yes, Bhanu Pratap Singh, 13 is the right answer. Let's do the question number 6. If 38 power 44 power 50 is divided by 23, in that case, what will be the answer? How would you solve this question? Can you answer this question? 38 power 44 power 50 when divided by 23, what will be the remainder? So the next level that we are supposed to do in today's class. So let me explain you the concept here. How you can use the Euler remainder theorem in this case also. 38 power 44 power 50 when divided by 23, what will be the remainder? Have to see that first condition that you are supposed to check is whether 38 and 23 are co-prime with each other. Yes, they are co-prime because 23 is a prime number. Now you can see that if these two numbers are co-prime, that means you can apply the Euler remainder theorem. Now after this, you'll have to see whether the power is a multiple of Euler number of 23 or not. Yes, Rajan, 1 is a right answer, because here if you check the Euler number of 23, the Euler number of 23 is 22, right? And if you talk about the power is 44 power 50. Now 44 power 50 is a multiple of 22. Why? Because 44 is a multiple of 22. 44 divided by 22 is 0. Remainder is 0. So in that case, 44 power 50 when divided by 22 will give you a remainder of 0. That means power is a multiple of Euler number of 23. Now if the power is a multiple of a Euler number of 23, you can say the answer to this question, that is remainder will be 1, right? So this is the Euler remainder theorem, that if power is a multiple of Euler remainder theorem, if power is a multiple of a Euler number of denominator or the divisor, then you can straight away say the remainder will be 1 if the first condition is getting satisfied. So I'm moving to the next question, question number 7. How would you solve this question? Find the remainder when 57 power 65 raised to power 59 is divided by 17. In this case, what will be the answer? So Rajan, I'm giving you a minute to solve this. Find the remainder when 57 power 65 power 59 is divided by 17. Try to use the Euler remainder theorem in this case. What will be the answer? So let's discuss it. This number 57 power 65 power 59 when divided by 17. What is the remainder? First check whether 57 and 17 are co-prime with each other. Yes, they are co-prime with each other. So that means we can apply the Euler remainder theorem. After this, find out the Euler number of 17. The Euler number of 17 is 16, right? Now you'll have to see whether the power is a multiple of 16 or not. In this case, power is 65 power 59. Very good, Rajan. 6 is the right answer. Now 65 power 59 when divided by 16. You can see that 65 power 65 power 59 is not a multiple of 16. But when you divide this power 65 power 59 with 16, you will get a remainder of 1. Right? Because 65 by 16 will give you a remainder of 1. 1 power 59 will give you finally will give you a remainder of 1. That means this is not a multiple of 16, but when this number is divided by 16 will give you a remainder of 1. So what you can do is you can remove, if you remove the multiple of 16 from this number, you will have a remainder of 1. So that means this number can be written as this with this power as a multiple of 16 multiple, and because the remainder is 1, so this would be written as 57 power 1 divided by 17, right? So this remainder 1 has been written separately. Now you can apply the Euler remainder theorem in this part, right? This will give you a remainder of 1, and what you will be left with will be only one number, that is 57 in the numerator. So 57 divided by 17 will give you a remainder of 6. So you will say the answer of this question would be 6. So 6 is the answer of this question. Anyone having doubt, please ask. Otherwise, I'm moving to the next question. You are supposed to remove the multiple of Euler number from this part, right? The multiple of Euler number of 17 is 16. So just remove the multiple of 16 from this number. If you remove the multiple of 16, you will be left with only one power, right? So this question will now become 57 power 1 divided by 17 will give you what remainder? So answer would be 6, right? So this is the application of Euler remainder theorem, that you can solve the questions with a composite index with the help of Euler remainder theorem. So I'm moving to the next question, question number 8. Find the remainder when 35 power 36 power 59 is divided by 11. What will be the answer of this question? Question number 8, 35 power 36 raised to power 59 is divided by 11. What will be the answer in this case? Rahul, 5 is a wrong answer. Please check your answer again. Anyone else? किसी और बच्चे का आंसर आया तो प्लीज कमेंट. Okay, so let me explain you the solution. Look, 35 raised to power 36 raised to power 59 when divided by 11, what will be the answer? 35 and 11 are co-prime. Yes, they are co-prime. So that means we can apply the Euler remainder theorem. So you'll have to see whether the power is a multiple of Euler number of 11 or not. 4 is also wrong answer, Rajan. 36 power 59, right? What is the Euler number of 11? Euler number of 11 is 10. So after this, we will divide the power with 10 and find out the remainder. Okay, and that remainder will replace this power. This is the concept of Euler remainder theorem that we have already discussed, that from the power you are supposed to remove the Euler, multiple of Euler number of 11. The Euler number of 11 is 10. So when 36 is divided by 10, what will be the remainder? Now this is an easy question of remainder, because 36, any power of 36 will have the 6 as its unit digit, right? Now if the unit digit is 6, the remainder will also be 6. That means from this power, when you remove the multiple of 10, the remainder will be 36. So now this question will become 35 power 6 divided by 11. Now when you divide 35 by 11, the remainder would be 2. So now this can be written as 2 power 6 upon 11. Now 2 power 6 is what? 64. Now 64 when divided by 11 will give you what remainder? 11 into 5 is 55. So answer to the question would be 9, not 4, not 5 also, right? Anyone having doubt, please ask. 9 is the answer of this question number 8. Have you checked your mistake, Rajan, Rahul and Bhanu Pratap? Please comment if you do not understand this question. Alright, so let's move on to the next question. Question number 9. Do this question. This is a bit advanced level question. 39 power 63 power 37 when divided by 11, what will be the remainder? Answer is not in the option. Ram Ram ji, Ram Ram. Please attempt this question number 9. Uttar Kumar Chauhan. Question number 9, please avoid the option. Answer is not in the option. (39 power 63 power 37). What will be the remainder? Uttar Kumar ji, attend all the sessions. Your maths will be the strongest part then. Don't worry. Yes, Ashish, I will be explaining you this solution in a minute. Please wait. Have you tried it by yourself? Okay. We will discuss it in a minute. Let the other people try. Hello, Ashish. Okay, so let me explain. See, the concept of Euler remainder theorem, right? We have already discussed it. So I'm discussing this question number 9 here. Please concentrate. I guess if you look at the solution of this question, your all doubts will get clear. See, 39 power 63 power 37 when divided by 11, what is the remainder? But that is what you're supposed to tell. Now you can see 39 and 11 are co-prime with each other, right? That means you can apply the Euler remainder theorem here. Now, what is the After that, the second step is to check whether the power is a multiple of Euler number or not, right? Just to explain all the students who have just joined the session, let me explain you a smaller question and then we will move to the next question. If I ask you that 37 power 102 when divided by 11, what will be the remainder in that case, right? Please listen carefully. What we will do is, first we will check 37 and 11 are co-prime with each other or not, right? Now they are co-prime, so that means you can apply the Euler remainder theorem. Now what is the Euler number of 11? The Euler number of 11 is 10. After this, what we will do is, we will write down the number as 37 power 100 into 37 power 2 divided by 11, right? Now this part will give you a remainder of 1 with the concept of Euler remainder theorem, right? So this is not now important to us. We can leave this part because this is ultimately giving us a remainder of 1. So what we are supposed to do is now to just take this part only, right? So we always remove the multiple of Euler number from the power, and the remaining part is remainder. This is what we are supposed to take it forward, right? So now we will solve this question as 37 into 37 divided by 11. Now 37 by 11 will give you remainder of 4. This will also give you remainder of 4. So finally you will say 16 by 11 and answer is 5, right? So what you are basically doing is, you are removing the multiple of 10 from the power and you are taking only remainder part. So basically you are supposed to find out the remainder by dividing the power with the Euler number of the divisor, right? And whatever is the remainder, that remainder will be assigned to 37, okay? Because this part will become 1. Exactly the same method will be applied to this question. But the problem is that here you have power of power. So what we will do is, Rajan, 3 is a wrong answer to this question. So I am explaining to a solution. Please listen carefully. Here in this case, what we will do is, we know that Euler number of 11 is 10. So from the power we will remove the multiple of 10. That means if you want to remove the multiple of 10, that means you want to find out the remainder when this number is divided by 10, right? So your purpose is now to find out the remainder when 63 power 37 is divided by 10, right? Now whatever is the remainder in this case, that remainder will replace this power. This concept is clear till यहाँ इस point तक सबको clear हो गया? Shall we move on to the next part? यहाँ तक clear होना चाहिए, right? 63 की पावर 37 को 10 से डिवाइड करने पे जो रिमाइंडर आएगा, that remainder will replace this power, right? Now our purpose is to find out the remainder when 63 power 37 is divided by 10. Now again you can apply the Euler remainder theorem here. Why? Because 63 and 10 are co-prime. 39 से 37. Uttar Kumar, I just explained this part as an example, right, of Euler remainder theorem for all the students who have just joined the session. This is a separate question, okay? This is not a part of the question. 37 power 102 when divided by 11. 11 Euler number is 10, right? So we will see out of 102 we will remove the power of 100 because 100 is a multiple of 10. Using Euler remainder theorem, this part will give you answer of 1 and you will be left with only this part. So 37 power 2, which is 37 into 37 by 11, which you can do it by basic remainder theorem. So answer will be 5. So what we are doing here is, we are removing the multiple of 10 from the power, and the remainder is replacing this power. Now 102 when divided by 10 give you remainder of 2. So finally the question will become 37 power 2 by 11. Exactly the same concept is supposed to be applied. Oh, very good Rajan, 7 is the right answer. So here in this case 11 Euler number is 10. So we will find out the remainder when 63 power 37 is divided by 10. Whatever is the remainder, that remainder will replace this power. Okay. So now let's find out the remainder when 63 power 37 is divided by 10. Again 63 and 10 are co-prime with each other. Now what is the Euler number of 10? 10 can be written as 2 into 5. So Euler number of 10 would be 10 into 1 minus 1 by 2, that is 1 by 2. 1 minus 1 by 5, that is 4 by 5. So 10 will get cancelled and you will have the Euler number as 4. So 60, now in this case again 63 power 37 upon 10, we will replace the power with the remainder that you will get when you divide 37 with the Euler number of 10. 37 by 4. Why 4? Because Euler number of 10 is 4. So 37 by 4, remainder is 1. Right? So this remainder will replace this power. So now this will become 63 by 10 and the remainder that you will get would be 3. Right? Now this remainder will replace this power. So this question can now be written as 39 power 63 power 37 divided by 11. Now this when divided by 10 give you a remainder of 3. So therefore this can be written as 39 power 3 upon 11. Right? So now 39 when divided by 11 give you a remainder of 6. So 6 power 3 by 11 and 6 power 3 is what? 216, right? 216 को 11 से divide करो, what will be the remainder? Answer would be 7. Okay? 216 when divided by 7, the remainder will be 7. So therefore the answer to this question would be 7, which is not in the option, right? 7 is the answer. Anyone having doubt, please ask. Okay? So I'm moving to the next question, question number 10. Someone who haven't understood the concept yet, you can go through the solution. I have written it down in detail. Okay, so you can go through it. So answer to the question will be 7, which is option number D here, which has been changed later on. Okay, so the answer is 7 to this question. You can pause the video later on and you can just read out the concepts, right? Or you can watch the video lesson again. Do the question number 10. Find the last 2 digit of 37 power 2842. What will be the answer of this question? This is also finding the last 2 digit is also related to the concept of Euler remainder theorem. With the help of Euler remainder theorem, you can also find out the last 2 digit of some questions. What will be the last 2 digit of 37 power 2842? 67 is wrong answer. Guys, let me explain you how to find out the last 2 digits. See, if I ask you, let's take a random number, a 3, 5, 6, 7, 8, 2, 3, 5, 2. If this number is divided by 100, what will be the remainder? The remainder will be the last 2 digit, right? The remainder will be 52 in this case. If I take another number, 7, 6, 8, 2, 3, 5, 2, 1. When this number is divided by 100, what will be the remainder? Again, you will say the remainder will be the last 2 digit. So, if you want to find out the last 2 digit, what you are supposed to do is just divide the number by 100 and find out the remainder. The remainder will be same as the last 2 digit. So, in this case, if you want to find out the last 2 digit of 37 power 2842, just divide it by 100 and find out the remainder. Whatever remainder that you will get will be the last 2 digit of this number. So our purpose is to find out the remainder when 37 power 2842 is divided by 100. Now in this case you can apply the Euler remainder theorem because 37 and 100 are co-prime with each other. Find out the Euler number of 100. 100 can be factorized as 2 power 2 into 5 power 2. So therefore the Euler number of 100 will be equal to 100 into 1 minus 1 by 2 into 1 minus 1 by 5, that is 4 by 5. So 2 into 5 is 10. So you will have the Euler number as 40. The Euler number of 100 is 40. So from the power, just remove the multiple of 40, or you can say Just find out the remainder when 2842 is divided by 40. What will be the remainder when 2842 is divided by 40? When 2842 is divided by 40, the remainder will be 2 in this case. Now whatever is the remainder will replace this power. So therefore replace this power with the remainder 2. So here you will have 37 power 2 divided by 100. So what is 37 power 2? It is 1369. Okay, 1369 by 100, so remainder will be 69. Okay, so therefore you will say the last two digit is also 69. 37 power 2 is 1369, right? It does not have the last two digit 67. You should remember square of at least 500 natural numbers. 500 natural numbers के squares आपको within seconds निकालने आने चाहिए if you want to get through the CAT exam, right? 31 power 961, 31 power 31 square is 961, 32 1024, 33 1089, 34 1156, 35 1225, 36 1296, 37 1369, 38 1444, 39 1521, 41 1681, 42 1764. Right? You should remember all these squares mentally. You should be able to find out the square mentally of at least 500 different natural numbers. I will take a session separately on this. Okay. So I'm moving to the next question. Question number 11. Find the last two digit of 47 power 81 power 2004. Solve this question. Do the question number 11. Find the last two digit. Now I have explained the concept that to find out the last two digit, you are just supposed to divide it by 100 and find out the remainder. So I'm giving you a minute. Please try this question and then we will discuss the solution. Find out the remainder when 47 power 81 power 2004 is divided by 100. Very good, Rajan. 47 is the right answer. The remainder will be the last two digit. Okay, this is an easy question. We have just find out the Euler number of 100 is 40, right? So just divide the power, that is 81 power 2004, with 40 and find out the remainder. Whatever will be the remainder, that remainder will replace this power. 81 power 2004 by 40. Now 81 by 40 is 1. 1 power anything will always give you a remainder of 1. So if the remainder is 1, that remainder will replace this power. So this now can be written as 47 power 1 upon 100. Now 47 by 100 will give you the remainder of 47. So the remainder is 47. So therefore you will say the last two digit will also be 47. So therefore the answer of this question would be 47. Alright. Yes, Ashish, 47 is the right answer. Question number 12. Find the remainder when 31 power 51 power 63 is divided by 17. So guys, let's discuss it. Anyone having answer, please comment. Do you need more time? Okay, Rajan, take a minute. I'm waiting. Okay, Guruji, I'm waiting. A 10 is wrong answer. Check your calculation, Rajan. I think it is a wrong answer. We'll have to see. Alright, so I'm explaining the solution. Concentrate now. Look, 39 power 51 power 63 when divided by 17. Okay, 39 and 17 are co-prime with each other, so you can apply the Euler remainder theorem. What is the Euler number of 17? The Euler number of 17 is 16. So just divide the power with the Euler number of 17, which is 16, and find out the remainder. And whatever is the remainder, that remainder will replace this power. Okay. So now 51 divided by 16. 51 divided by 16 will give you a remainder of 3 power 63 divided by 16, right? 51 divided by 16 is 3. So you can write it down as 3 power 63. Rajan, 14 is also wrong answer. So now 3 power 63. Here you can again apply the Euler remainder theorem. Why? Because 3 and 16 are co-prime with each other. And what is the Euler number of 16? 16 can be factorized to power 4. So Euler number of 16 will be 16 into 1 minus 1 by 2, that is 8. Now 63, from 63 just remove the multiple of 8. So 63 when divided by 8 will give you a remainder of 7. So now this remainder 7 will replace this power 63. So now this can be written as 3 power 7 upon 16. So now 3 power 7, what is 3 power 7? This can be written as 27 into 27 into 3. Right? 3 power 3 into 3 power 3 into 3 power 1 divided by 16. Now 27 power 16 will give you a remainder of what? 27 को 16 से divide करने पे कितना remainder आएगा? -5. -5 into 3. -5 into 3 is 75. 75 by 16. What will be the remainder when 75 is divided by 16? This would be 11, right? So now this 11 remainder will replace this power, right? So your question will now become 39 power 11 divided by 17, right? So I'm removing what I have just written down. So finally our question will become 39 power 11, that is supposed to be divided by 17. Now 39 when divided by 17, what is the remainder that you will be getting? 17 into 2 is 34, so you can write it down as 5 power 11 upon 17. So now 5 power 11 is what? This can be written as 5 power 3 into 5 power 2, that is 25. Now 5 power 3 is 125. 125 when divided by 17, 17 into 17 into 6 is 102. 17 into 7 is 119. So 125 minus 119 is 6. So this will give you 6 power 3 into 25 by 17. So now this will become 216 into 25 divided by 17, which 216 divided by 17. Find out what will be the remainder. 216 को 17 से divide करने पे कितना remainder आएगा? 17 1 4 34 12. 12 into 25 को 7 से divide करो, you will get a remainder of 8. Now 12 into 8 is 96. 96 when divided by 17. 17 into 5 is 85. So 86 minus 85 is what? 11. So answer is 11. So Rajan, answer is 11. Rajan, Ashish, have you understood this concept? 11 is the answer. If you are getting any mistake, please ask. If you are having any doubt, please ask. 11 is the right answer of this question. So guys, these were the questions that I was wanted to discuss with you. This was the second part of Euler remainder theorem, where we have discussed the advanced level questions with the help of remainder theorem. Alright. So yes, Prikshit, 11 is the right answer. Very good. So I'm ending the session here. So see you then in the next session with a new topic. Thank you so much for joining the session. Right. Bye bye. Good night.